All right, so let's keep trucking. Everybody can see what's on the screen here. Okay. So last class, we had homework, write the necessary code to display the contents of a string in reverse, 1 character per line. So we'll go ahead and write that real quick, and then we'll convert it into a method, and then we'll start. Well, then we'll just keep trucking here. Pun intended. All right. So here, I'll just give ourselves a starting string. So we learned about some of our string methods last time. So this is just kind of putting some of those to use. So we're going to write a for loop that's going to go through this string from the end to the beginning, because we want to do it in reverse. So we're going to say for int I is equal to the last legal bucket of our string is s dot length minus 1. Okay, if a string has a length of 5, the legal buckets are 0 to 4. So we'll start off at length minus 1. We'll keep going as long as I is greater than or equal to 0. And we'll subtract 1 from I each time. And we will print out s dot char at I. So this will get the character that lives at position I in the calling string s, printing it to the screen. And since we're using println, it will do it, print the character and then kick it down the line. So there's the string in reverse. Go ahead.
So basically s dot char at the print reverse of C++. Or like C++, we would use print reverse.
This part right here?
Yeah.
Well, s dot char at I, the equivalent in C++ would be that. This whole function we're writing would effectively be print reverse, but s dot char at I just says, give me the character that lives at position I in the string s. Now, if we wanted to move this into a function, maybe called print reverse, we'll come down here. We're going to have a function that returns nothing. And remember, right now, all of our functions are static. We'll talk a little bit more about that today, as far as the why, and then we'll get some experience in doing it over the next several weeks. So this function is going to return nothing. It's going to do something. It's going to be printing a string in reverse, 1 character at a time, but it's not going to return anything. So its return type will be void. And we'll call this guy print reverse. He's going to take a string as a parameter. And I'll just take our logic here, actually. And since I happen to name my parameter s, I'm already good with the variable names I have in here. So this guy will work just like that. He'll take a string as a parameter named s. He'll go through that string from end to beginning, whatever that string is, whatever was passed in, he's going to go through it, and he'll print out 1 character at a time. So now I can say print reverse s, and we'll get the same output. Similarly, I can call that same ability again, maybe passing it elephant, and now I'll get elephant in reverse as well as hello in reverse. So we put it into a function because we want to write it once and call it multiple times. All right, and we wrote this in C++ last semester. So really, we're just learning the Java version of some of these string functions. Okay, so now I want to talk about a class called the character class. And before we get to that. I'm going to open up a couple of tabs here. Let's scroll down to the list of functions. Method summary here in the character class. And I'll scroll down to our method summary here in the string class. Now, up to this point, all of our methods that we have written, we've put static in front of. Notice that the character class has static in front of all their methods, a high percentage of their methods. The string class does not. All right, we're going to attempt to try to understand why that is with what we're going to look at today. All right, so let's just look at the character class, and I could have picked a couple of different classes here, but the character class will really drive home another point we made before. So inside the character class, we have several functions. One of them is called toUpperCase. All right, now I know we had a string. Someone go ahead and say string methods continued. The string class also has a toUpperCase method. All right, so the character class has a method called toUpperCase that takes a char as a parameter and returns a char, presumably the uppercase version of that character, right? The string class has a method that takes no parameters called toUpperCase that returns a string. Why does, and let's just kind of see this in action. So if I say system.out.println s dot toUpperCase, we'll get hello in all caps. So there's hello in all caps when I had originally defined it in lowercase. Now it did not change s permanently. It just boiled down to a string that happened to be the all uppercase version of s. So you see that s is still equal to hello in all lowercase. All right. So first question I have is, why did we not need to pass any parameters to the toUpperCase method of our string class? Again, showing it to you on the method definition side. The toUpperCase method for strings takes no parameters and returns a string. Why did I not have to pass any inputs to this toUpperCase method? Go ahead.
Because the function is acting on the variable that you're placing after.
Yeah, so this function is being called by the string we want to convert to uppercase. Will that work? Okay, so your answer is yes. So my follow-up is why? This guy is a string. What is s? That's it. S is a variable that boils down to a string. So at the end of the day, s is going to boil down to hello. That's what it's going to end up actually operating on. We're going to be calling the toUpperCase method, which belongs to the string class, on a particular instance of a string, either hello, or in this case, elephant. Usually we would call it on a variable that's holding a string rather than a hard-coded string. Because why wouldn't we just type out elephant in all caps? You know, we could just do that. Okay, but we'll see that this guy still works. All right, but the punchline for us here is the reason that the two uppercase method for strings does not require an input, does not require a parameter, is because it already knows about the string that you want to convert to uppercase. That is the calling string, the instance of the string class that called that method. Make sense? All right, now the antithesis to that is notice here in the character class, that particular method called two uppercase does take in a parameter, and this method is a static method. Now, we've been cheating a little bit up to this point, although we've seen it work, but we're going to explain why it worked today. Realistically, the name of my class here is called main, even though I didn't like it naming main the same as my function name, but whatever. The name of my class is main, and I wrote a static method inside of main called print reverse. I would say static methods or class methods are always called with the name of the class in which the method was defined. So main.print reverse, that is the print reverse static function that belongs to the class called main. Now, the reason why we didn't have to put main in front of this is because this method, main, the method we're currently in, main, is a static method that lives inside of main, the class. That means our current context is we are inside of the class called main. Therefore, I have access to all the class methods of main. Just because you can call the method without the class name, I always recommend always using the class name. If for no other reason than most IDEs you use for coding will do command completion, so you'll have less error, you have less misspells. Go ahead.
So if you were to do it outside of class main, you would need to use the main dot before everything.
If I were to do it outside of,
Or just like renaming something.
you mean outside of this class main?
Yeah, that's it.
Not outside of, see, that's why I hate having these two named the same. If you did it in another function like this, void do something, and I made that guy not a static method, and then I called this guy print reverse like that. Question is it going to actually show up as an error? Might not. Yeah, Java figured it out for us. All right, but we're going to say that this is not accurate because I am in this function, and this function is not a static function. This function lives inside of the class called main, which is why Java was able to figure it out. But my current context in here, well, let's see. I am in an instance context of the main class. Every single instance of the main class will get its own copy of this do something method because I didn't put static out front, as opposed to the print reverse method here only exists one time because they put static out front. But I would say any method that starts with the keyword static, you call using the name of the class in which that method was defined. We'll put that in the notes here. Static versus non-static, and I'm going to put in parentheses here, instance methods. Static methods start with the keyword static. are owned by the class itself, not a particular instance of the class, are called using the name of the class as opposed to an instance of the class. We'll see the differences between those here in a few minutes. They're called using the name of the class as opposed to an instance of the class. Non-static methods do not start with the keyword static, are owned by a specific instance of a class all instances get their own copy of this method, are called using an instance of the class in which it was defined. I'll throw that up here too, in which it was defined. So not just any old class, it has to be the class in which that method was written. So in this case, we wrote our method inside of our class called main. I'll say as opposed to the class name itself. All right, so that's the difference between class methods and static methods from the perspective of, hey, I saw it in the documentation, or I wrote it myself just because my professor said always put the keyword static out front. And since he said always put the keyword static out front when I write my own methods, that means my methods are of this type. Why? Because it started with the keyword static. Therefore, it's owned by the class itself, whatever that means. So I call it using the name of the class. Main dot print reverse has static out front. So I call it using the name of the class. This main, not this name of this method here. They both say main, but this one starts with a capital M. And I hate that they default the name of your thing classes to main in here. Go ahead. Change the second one. This guy here? Oh, this? No. All programs begin and end with main. That goes back to last semester. That guy has to be called main. Top one can be called anything, and really it should be anything except the word main. Because it just becomes, there's nothing wrong with the word main. It's just difficult to talk about these guys as being two separate kinds of animals. This guy is a class that happens to be called main. This guy is a method that also happens to be called main, but with a small m. So from Java's perspective, they are not the same thing. Java is case sensitive. Okay, but I would typically call my class that has my main method in it, I usually call it driver. But if I do that here, it's going to scream at me for a couple different reasons. Here, I'll change these all to driver. So I'm going to call these methods using the name of the class in which it was defined. But we're going to see that it's going to scream at us saying, class driver is public, should be declared in a file named driver.java. Well, it just so happened it wrote this guy inside of a file called main.java. And I don't think, I don't see a way of changing the name of my file. Does anybody know how to do that in here? Yeah, but I think creating another file. I wonder, can I get to a console here? It's really frustrating. I can rename the project. It just won't let me get to the actual file system to change the name of it. Oh, well. So we'll just live with it for now. Okay. So since we wrote that method, we put the keyword static in front of it. We don't know why, other than I told you you had to. That's where we're at right now in terms of our knowledge about this, right? I said you have to. Okay, that's going to change relatively soon. All right. Now, if we're looking at non-static methods, for example, we look at the string class here, and we look at char at, this method right here. It's one of the guys we've used. We see there is not a keyword static in front of this guy. If we go and look at toUpperCase, here's toUpperCase. There's not a static keyword out front. It returns a string. It's called toUpperCase. It takes no parameters. As opposed to the character class's version of toUpperCase. This guy right here just takes in a char, returns a char, but he's static. We still don't know why. We're going to try to discover why today, right? But we do see that they are defined differently, right? One of them happens to take in no parameters, returns a string, and does not have the keyword static in front of it. The other one does take a parameter, returns a char. So they both return a value, but one of them takes an input, the other one does not. But that guy actually is static. The one that takes a parameter is a static method. So since the character class has a static method called toUpperCase, how do we call static methods? They're called using the name of the class in which it was defined. So this guy was defined inside of a class called character. So out here, I can say system.out.println character.toUpperCase. Maybe I put in a lowercase c. And now when I run that, I get an uppercase C. Now, let's assume that you didn't know that the toUpperCase method of the character class requires an input. What we're trying to discover is why. Why does it require an input? What would you expect the output of this line to be? Just looking at it from a common sense perspective, what would you expect the output of that line to be? Go ahead. What character?
The word character.
Oh, the word character? What's that guy? What kind of animal is that?
That's not a
Yeah, so he would only be a string if he was surrounded by the double quotes, right? Okay, but that's not a horrible answer. Just if it looked like that, we'd expect capitalized character, right? Absolutely. Okay, but we didn't have the double quotes there. So it's either an error, right? Because we didn't have a variable named character, but we've noticed that we do have a class named character. So assuming we know that this guy is the class named character, but we don't necessarily know that the toUpperCase method takes a parameter. And let's just say we didn't get an error from this. As a human being, if this was the name of a class and we were calling a function called toUpperCase, what do you expect a function called toUpperCase to do? Convert something to uppercase. It kind of sounds like what that guy probably does. He does an uppercase thingy. All right. What would we expect the output of this line to be? Who knows, right? What are we converting to uppercase? We didn't give it anything. But why did we have to give it something? Okay. You mentioned the reason we didn't have to give a string something in its toUpperCase is because this function knew to operate on the instance of the class that called it. This version of that function knew to operate on the instance of the class that called it. With instance methods, non-static methods, they know about stuff involving the instance of the class that called the method. In this case, I don't have an instance of a class. I just have the name of a class. And the name of a class doesn't necessarily have a unique state. We didn't build an instance of character putting in the letter C or putting in the letter W or whatever. So when I say character class, call your toUpperCase method, I'm calling upon the one toUpperCase method that exists in the character class that knows how to convert a character that you pass it to uppercase. But if I don't pass it anything, it doesn't know what it's going to operate on. We can almost think about methods that are static methods that belong to a class. We can kind of think about them like a factory. All right. You have this single machine that knows how to, if you drop a char into it, it spits out the uppercase version of that char. Right. But if you don't drop a char in there, it's not going to spit anything out. That makes sense? That machine requires an input in order to be able to do its job. All right. Now, because the documentation says, hey, this guy is a static method. We'll get to why they made it a static method in a minute, but punchline is they did, right? For whatever reason, they made it a static method. This tells us how to call that function. Even though not until today, most of you have never seen this class before, we know that since it's static, we're going to call this guy using the name of the class in which it was defined, which is the character class. And we know its name is toUpperCase. We know it requires a char in order to work. We have to give it something in order to work, and it's going to spit out a char when it's done. And we can take a pretty good guess what this guy is going to do by his name, toUpperCase, but we can also read about it here. Tells us what it does. Okay. So that's why we would call this using the name of the class. Character dot toUpperCase C. Character dot toUpperCase Z. Go ahead. For the most part, yeah. Oh, you should have all of them memorized. Yeah, and actually that's the point of what we're doing here. Nobody, I mean, I've been programming in Java since it came out. I probably know 15% of the language, and that's probably. You would look it up. Yeah, for instance, if you're like, hey, I have a char. I kind of need to turn this guy into uppercase. I wonder if there's a function that might do that for me. And you just happen to say, well, I'm dealing with chars. You're scrolling through like, oh, there's this character class. And we're going to give you a punchline to that in a second. But you look at the documentation and say, might there be a tool laying in there that might operate on chars? And then you go and say, well, what does that guy know how to do? So it's less about memorizing stuff. I mean, if you use something very often, you're going to accidentally memorize it, right? Okay, but the whole reason that we learn to read the documentation is so that you don't have to memorize those things that you use once in a blue moon, right? All right, so now this character class is built, like you mentioned, seems to have just a whole bunch of functions in it, okay? And if you notice here, a lot of these functions take chars as parameters, or they all take some kind of parameter, some kind of inputs. All right, now. What is a char? So we've already looked at some of these things, right? We said, okay, well, a char is actually an unsigned 16-bit integer. That's what kind of value it holds. But it belongs to, it is one of our primitive types. What does it mean to be a primitive type? I think I kind of gave a definition to this last class or the class before. Go ahead. Built into language, that's true. What else? What else is go ahead. All it can do is hold a value. So for example, a char, since it's a primitive type and it can only hold a value, it can't convert itself to uppercase like a string can. Make sense? Strings are object types. So they have all sorts of crap that they know how to do. And somebody who was writing it, the people at Sun Microsystems, when they were creating the language, they decided, you know what? Somebody might want to convert a string to uppercase. So we're going to go ahead and build that into the language. We're going to make that a tool that's part of the language. Okay. Now, is it equally reasonable for us to say somebody might want to convert a character to uppercase? It's also a reasonable thing to say, but we have a problem. Chars are primitive types. All they can do is hold a value. We can't, no matter how much we want to, we can't teach a char to do extra magic tricks because all it knows how to do is hold a value. But what we can do is we can create a class filled up with a bunch of class methods that know how to operate on chars. Make sense? The character class exists to do stuff to chars because chars can't do things themselves. And I think you'll find if you go and look at the documentation here, let me just get to, I think it's under frames. That'll show us the, if we pick another one of our primitive types, like maybe, I got to go down to the eyes. Well, actually, I could have stuck with B for Boolean. So there's another one of our primitive types here called Boolean. So it's a class that knows how to do a bunch of stuff, static methods operating on Booleans. We have another one called integer. We have another one called byte. We have another one called double, so on and so forth. There exists in the language counterparts to all of our primitive types that allow us to do some maybe common sense things that we might want to do to that primitive type because those primitive types can't do it themselves. That makes sense? Okay, that's why the character class exists. Now, why are the methods inside the character class static methods? They're static methods because the things that we are operating on are not instances. They're not object types. Therefore, I'm not going to have multiple instances of a character. You actually can create an instance of a character class, and that's a little bit of a different thing. But for the sake of this argument, let's say you're not going to have instances of chars because they're primitive types. Therefore, what we really need is a function, a factory type function that we can write once, stuff into the character class and say, hey, whenever you want to do something to a char, check with the character class to see if he already knows how to do it. And if he does, you're going to have to toss him the char that you want him to work on. But because he requires a parameter, well, not so much because he requires a parameter, because he does not know about any additional information. He doesn't have any additional state that the end user gave them. You're going to have to tell that function the value you want it to operate on. That's why we have to give the to uppercase method in the character class a parameter. Otherwise, it doesn't know what you want to convert to uppercase. Whereas the string class, which is filled up with non-static methods, it's going to assume you're going to call that guy. We call non-static methods. They're called using an instance of the class in which it was defined. And that instance is going to be the guy that gives him the value that it's going to operate on. Now, that doesn't mean that instance methods will never have parameters. You might want to do something else. Like, for instance, the string class has the char at method. That guy does take a parameter. He takes a number. What's the number for? It's the number says, what character do you want me to return? What is the index of the character of the calling string that you want me to return? We use that guy right here. So S is my string. This instance of char at knows about what S holds, whatever string that is. But I still needed to give that guy a bit more information. I need to say, give me the char at this position within this string. Does that make sense? So it's not as easy as saying, oh, non-static methods will never have parameters. And static methods will always have parameters. We wrote a static method in our code. Here, this guy, there's a static method that takes no parameters. It might not do something that's all that great, but it's legal. You can create a static method that doesn't take any input, but he's not going to know about really anything. He's not going to have any state on which to operate. All right, that makes some sense. So at this point in time, what we should understand is why the string class is filled up with a bunch of non-static methods, because the presumption is you're going to create a whole bunch of different instances of strings, and then you're going to call those methods using each of those instances. So it already has state on which to operate, even if some of those methods will take some additional parameters. And then we'll understand that there is, for example, the character class, which happens to exist to do things to chars, because chars can't do it to themselves. And that class happens to be filled up with a bunch of static methods. Okay, it's a method that's owned by the class itself, because we're not going to have a whole bunch of different instances of characters. Instead, we have a whole bunch of chars. We wouldn't call them instances of a char because they're not object types, and only object types can be instances, let's say technically. But we have these char primitive types, which we know are lackluster. All they can do is hold a character. But we might want to operate on them. That's why classes like the character class, like the integer class, things like that, that's why those exist. Make some sense? Okay. Now, if we're writing our own functions here, why do we make them all static? Because right now, all the functions we're writing live within the same default class that is where our main method lives. When the reality is, if we're writing a typical computer program, we would probably have a class where main lives, and then we'd have other files where we're defining objects, and those files would have those methods built into it. Let's kind of show that as an example here. So I'm going to go ahead and create a new project. Let's see what I can get away with here. And it's not going to let me name the thing anything other than main. It seems terrible. Huh? This thing's been out for a while. It's one of those perpetual betas. All right. Yeah, but I don't want to support other IDs. All right. So I'll just go ahead and then create a project here. 250 objects. All right, so there's my main method. Right now, if I ran this, it would do nothing. All programs begin and end with main, fine, but main says don't do anything. Waste of time. All right. Like I mentioned, I would usually name this guy driver, but they're not letting us do that, so that's fine. I name a driver because this is the file that drives the program. That's why I call it driver. But for our intents and purposes, whatever file has our main method in it, that's where the program starts. All right. So what I'm going to do is I'm going to go ahead and create another file. And we're going to call this guy string helper. Okay. So string helper, we're going to have public class. And actually, hold on, does that automatically create a? Yeah, it's going to be bad for us. Oh, that's rich. You can rename this file. It's not the original. All right, so this guy's actually going to be called stringhelper.java, not just string helper. All right. So this guy is going to be public class string helper. You actually don't have to have public on it, but it's not going to hurt anything. All right, string helper. Actually, let's just leave it as class string helper, so we don't have extraneous things. So class string helper, we'll talk about public, private, protected. We talked about that some last semester, so that's not a whole new idea. All right, class string helper, and we're going to go ahead and say that string helpers will operate on strings. All right, so we're going to have a private string. Maybe we'll call this guy the string. Then we're going to have a public string helper. We'll have this guy taking a string that it's going to operate on. We'll say this dot the string is equal to the string. And then we'll say public void print reverse. So notice I did not make this guy static, and I also didn't have him take any parameters, because the string that he's going to print in reverse is the string that this class already knows about. And you'll see this by example here in a few minutes. So I'll go ahead and say for int I is equal to 0. Is equal to this dot the string dot length minus 1. I is greater or equal to 0, I minus minus. So we'll write our loop that goes from the end of the string, that is the string that is owned by this. Remember that this keyword is how an object refers to itself or within itself, just like in C++. And we'll say system.out.println this dot the string dot char at I. And technically this dot is not required here, but just like I said, when you are calling class methods, you call them using the name of the class in which the class method was defined. Instance methods are called using, or instance fields are called using the instance in which that thing was defined. And in this case, since we are inside of a class, the way we talk about this particular instance is through the keyword this. But I'd also argue that this will make you have less spelling errors. You say this dot, it'll show you the stuff you have available to you, and you just press enter on what you have. All right. So here's a class in Java. Remember last semester we had kind of a private section and a public section. Now you just name each individual element whatever you want. So I'm going to say, hey, this field, which is our variable, he's going to be private. Then I need a constructor. Notice the constructor's same name as the class name, just like C++ required. All right, he's going to be public. He's going to take in whatever parameters we're going to have. This is something just like we did in C++, right? We set the field owned by this class equal to the parameter that was passed in. And that allowed us to have those guys have the same name. Nothing says these have to have the same name. This guy could have been called LOL, and we could call it LOL there. That would have also allowed us to do this. But if we had this called the string and we wrote that, that no longer makes sense. Variables resolve to their most local definition. So that means when I say the string there, even though I mean this guy, it's going to resolve to this guy because that's the most local definition. But if I put this dot in front of it, I'm giving it the full path. I'm saying I'm talking about the version of the string owned by this particular class. And I want to set it equal to this guy. Okay, so all these are instance functions. So I'll go into main. Now I don't need to include anything. I don't need to bring in the header file or anything like that. I can just say string helper sh1 is equal to new string helper. I'll pass this guy hello. I'll create a second instance of this guy, storing elephant. And now I can call print reverse. Notice here that print reverse is a non-static method. We call non-static methods using an instance of the class in which the method was defined. So I need an instance of string helper. Right here, we have an instance of string helper called sh1. We have another instance of string helper called sh2. And now we get those guys printed in reverse. So same logic, but we built it into our own object with all the guts kind of sucked inside. Make sense? All right, questions, comments, concerns, bribes. All right, we'll come back on Wednesday. We'll pick up from here. We'll probably have an assignment on Wednesday dealing with creating objects, but I'd encourage you to go and kind of play with this stuff to work on getting the that concept of how objects work in Java moved over. Hopefully you see they're very, very, very similar to what you've already done. And I'll put a link up to this on Slack if you want to come and play around.